next couple of slides, and for the next 6 questions, 6 problems, we're going to look at either dividing by a radical, which we will call rationalizing the denominator, or using the conjugate, which we'll talk about when we get to part C, using the conjugate to help simplify a radical expression or a complex number. So with these 3, we're dealing with radicals, and we'll look at part A. And so it's not considered simplified if I leave a radical in the denominator. So the process is to take what's in the denominator, the radical part, and multiply as a fraction. The square root of 12 divided by square root of 12 is equal to 1, so it doesn't affect multiplying this by 1, so it doesn't really change the problem. So then it allows me to multiply these 2. That would give me the square root of 180. And the square root of 12 times the square root of 12 is the square root of 144, which is 12. So again, we want to look at simplifying the square root of 180. And that would be the square root of 36 and the square root of 5. So this simplifies to be 6 times the square root of 5. So I get 6 times the square root of 5 divided by 12. And what I'm looking to simplify is this fraction, 6/12, which becomes 1/2 times the square root of 5, or the square root of 5 divided by 2. So either one of those 2 would work. All right. Part B, we've got the square root of 4 divided by 2 times the square root of 20. Again, I don't want a square root in the denominator, so I don't have to multiply by the square root of 2, but I could simplify the numerator. So I've got a lot of choices of where to start. So if I go ahead and simplify the square root of 4, that gives me 2 divided by 2 times the square root of 20. And since this is really 2 divided by 2 times 1 times the square root of 20, I can go ahead and divide that, which goes to 1. So now I'm left with 1 divided by the square root of 20. And as we noticed in the problem before, it's not simplified to leave the radical in the denominator. So I'm going to multiply by the square root of 20 divided by the square root of 20. So I come over here, and that's going to give me the square root of 20 in the numerator. And the square root of 20 times the square root of 20 is the square root of 400, which is 20. So now all I need to do is simplify the square root of 20, which would be the square root of 4 times the square root of 5. And we know that would be 2 times the square root of 5. So that's in the numerator, replacing square root of 20. So I get 2 times the square root of 5 divided by 20. And again, I'm looking to simplify 2/20, which would be 1/10 times the square root of 5, or the square root of 5 divided by 10. Either one of those would be a simplified form. And then part C, I've got 3 divided by 4 plus 4 times the square root of 5. So in this last one, it's a little different because I've got 2 terms. So therefore, I'm going to apply the conjugate, which we learned in Unit 1, that if you difference of squares, remember it's the difference of squares result, and if I multiply this out, I end up losing the middle term, so I'm left with a squared minus b squared if these were my factors. So that's what I'm going to do in this case. I'm going to multiply by 4, and this is 4 plus 4 times the square root of 5, so I'm going to multiply by 4 minus 4 times the square root of 5, 4 minus 4 times the square root of 5. And I'm going to go ahead and multiply like I know how. So that would give me 12 minus 12 times the square root of 5, all divided by, and then I would multiply out your two factors here. I get 4 times 4, and I get 16. And I get 4 times a negative 4 times the square root of 5, which would be negative 16 times the square root of 5. And in the middle here, I would get 4. That's not correct. I would get positive 16 times the square root of 5. And then the last two terms, and I'm going to get negative 16 times, and the square root of 5 times the square root of 5 is the square root of 25, or 5. So I just need to clean up the denominator a little bit. So I'm going to rewrite. So 12 minus 12 times the square root of 5, all divided by. And notice the two middle terms divide out. So I'm left with 16 minus, and 16 times 5 would be 80. So continue on, and I've got 12 minus 12 times the square root of 5, all divided by, and that would be negative 64. So what I have is negative 12. Just going to take the negative to the numerator. So I got negative 12 divided by 64. And then this term is negative 12 times the square root of 5 divided by negative 64. That's going to be a positive. So what I'm doing is I'm looking at simplifying these two components right here and here. When these two shared the negative 64 as a denominator, I could write it as two fractions. So that's what I want to do. I want to simplify this piece, and then I want to simplify this piece. So they're both divisible by 4, so that would give me negative 3/16. And same thing here. I'm going to get positive 3 times the square root of 5 divided by 16. Notice the denominators are the same. So we're allowed to write it as negative 3 plus 3 times the square root of 5. And all divided by 16. So again, this was problems that dealt with rationalizing or multiplying by the conjugate to simplify a radical expression. The next 3 examples will involve working with imaginary numbers. And as we couldn't have the square root or the radical in the denominator, we don't need to have I in the denominator. It's not considered simplified. So what we know, I is equal to the square root of negative 1. We also know I squared is equal to negative 1. So we're going to definitely utilize this equation. So if I'm looking at part A, I get 10 minus 10i divided by negative 5i. So to eliminate this I in the denominator, I'm going to multiply by negative 5i, and I'm just going to multiply by both of the terms, and that's going to give me negative 50i, and this will give me positive 50i squared, all divided by, now what's negative 5 times negative 5i times negative 5i is going to be a positive 25i squared. And we know I squared to be negative 1, so 50 times negative 1 will give me negative 50, and 25 times negative 1 will give me 25. So remember, as I'm allowed to write negative 50i divided by 25, and this would be a negative 50 divided by negative 25, so that's going to change to a positive. So I want to simplify what I can, and 25 will divide negative 50 negative 2 times, and 25 will divide 50 2 times, and remember our notation is A plus bi. So we're going to write it as 2 minus 2i. And that is part A. Part B. Scroll on down. And B is going to be 5i divided by negative 2 minus 6i. So the same idea. I have two terms here, so I'm going to multiply by the conjugate, which would be negative 2 plus 6i, all divided by negative 2 plus 6i. Because remember, what is negative 2 plus 6i divided by negative 2 plus 6i? It is 1, and multiplying by 1 does not affect the problem. So I'm going to multiply the numerator by both terms. So that's going to give me negative 10i and 30i squared, all divided by multiplying by the conjugate. So negative 2 times negative 2 would give me 4. That'll give me negative 12i and a positive 12i and a negative 36i squared. So we see, multiplying by the conjugates, we do lose the two middle terms. So the numerator is negative 10i, and I squared is negative 1 times a positive 30, so that's going to go to negative 30. And I get 4, and this is minus 36, and we know I squared is negative 1, so that will be a positive 36. So I get negative 10i minus 30, all divided by positive 40. And as we can see, there is a factor of 10 in every one of these. So that would be negative 10 divided by 40 plus negative 30 divided by 40. And that's 10i, sorry. So this would simplify to negative I divided by 4. And then negative 3 divided by 4. Since we're sharing the same denominator, we can write it as negative 3 minus I divided by 4. So what is the, we write it in this A plus BI form. Well, what is A? Well, A would be negative 3/4. And what's BI? It would be the negative I divided by 4. So these would actually be the same. All right, and then the last one, part C, is negative 4 plus 10i and 3 divided by 3 plus 4i. So negative 4 plus 10i, all divided by 3 plus 4i. Again, we got the two terms with the imaginary number I, and I want to simplify this. So I'm going to multiply by the conjugate. So this is 3 plus 4i. The conjugate would be 3 minus 4i. And then we're going to multiply and multiply. So I get negative 12 and a positive 16i, and then 10i to both of those, so that'd be 30i and negative 40i squared. And then below we would have 3 times 3, so we would have 9, and that would be negative 12i, and that would be positive 12i. So we see the middle terms eliminate again, and that would be negative 16i squared. So we know this is negative 40, and this is I squared, which is negative 1. So this is going to be negative 12 plus 40, and then the 16i and the 30i would be 46i. And then we notice those divide out. That's negative 16. I squared is a negative 1. So we're going to get 9 plus 16. So here we're going to get 28 plus 46i, all divided by 25. And in this case, you could definitely simplify this, or try to simplify this. It would be 28 25ths plus 46i divided by 25. And you would look to see what you can simplify. But 25 has a factor of 5. 28 does not, so that's going to be fine. And 46 does not divide 5 evenly. So what we have is our final result.